Woohoo! We are here today to talk about 5.2 logarithmic functions and their properties. Yay! And because logarithmic functions can be a little squirrely, I've asked my friend the squirrel, and by the way, that is an acorn. I've invited my friend the squirrel with his acorn to come help us with logarithms. Now, logarithms were developed before there were calculators to help folks with calculations that were really difficult to do using, just working by hand. We've inherited logarithms, even though we now have computers, because logarithms are actually helpful in and of themselves. And I'm happy, I'd be thrilled to talk to you about all the various wonderful things we can do with logarithms. But for our class, I want to review some very specific uses of logarithm. Specifically, that logarithms help us work out exponentials. So here we're going to go through and I'm going to talk about something that I hope you've seen before, but it's okay if you haven't. So we're going to start here and say, by definition, if you have 2 cubed equals 8, and let me write that out again, in case I'm sorry, squirrel, equals 8. So 2 cubed equals 8 is the pronunciation. That's the exponential form. And it's an exponent. 2 raised to the third power means 2 times 2 times 2 equals 8. Then it is also true that, and the way you pronounce this is log base 2 of 8 equals 3. Log base 2 of 8 equals 3. Like that. Now, why do we say log base 2? Well, up in the exponential version, you see that 2 is the base, and 3 is the exponent. And you'll notice that this says this has a 2 and a 3 and an 8, and this logarithm has a 2 and an 8 and a 3. So the same digits just moved around. So what the heck are we even talking about? Is logarithm just a made-up thing? And I think partly the answer depends on the person you ask. I would say my perspective is it is rooted in history and it was a made-up thing. It is something that was invented to help folks come up with other solutions. So it's a helper. It wasn't nobody was walking through the forest and found, a squirrel that had dug up a logarithm. As happy as the squirrel is, no squirrel, I think, has ever found a logarithm underground or under a tree or something. They don't fall and hit anyone on the head. They don't happen when you jump out of a bathtub. Logarithms were actually something that someone was searching for in terms of kind of an algebraic way to work with exponents. So what are we talking about here? Well, let's look at what this actually means. When I say log base 2, I'm saying, okay, I want you to think in terms of 2's. Everything is in terms of 2's. And if I have an 8, that is 2 times 2 times 2, right? So how many 2's multiplied together give you 8? Oh, 3 of them would give you 8. So the answer when we're saying how many 2's multiplied together? 3 of them. So that's what logarithm asks. Logarithm says, what is the exponent for the base we have specified? So what I've done is I put this in a box, and if you're anything like me, the first or second time I read this was like blah, 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 blah. However, it actually is really useful. It gives you the pattern, but I have to admit it's often easier to understand this pattern after we've done a little practice. So, sorry about the airplane if you can hear it. I live really close to the airport here. So, if A raised to the bth power equals C, then let's look at the logarithm. It's going to be log base A, right? That's the base in both cases. But notice the C and the B switch places because I'm saying how many A's multiplied together give me C? oh, I had to raise a to the bth power. So that's this over here. And you'll notice that the a's have the same rules that they did when we were talking about exponential functions. No negative, no 0, no 1. But then we're also going to specify that logarithms don't know what to do with a negative or a 0 if you stick it in. So just avoid that. Just know that it's just not going to make any sense at all. Okay, so I know at this point everyone's like, what is even happening here? So I'm going to first, with these 3 examples, we're not going to solve anything. We're not going to set anything equal to anything. All we're going to do is we're going to take this exponential like this. 3 squared equals 9. And I'm going to say, okay, let's look at that in terms of the logarithm. So a logarithm is going to have log, and then I've got to write the base. And the base gets written slightly lower. It's a subscript. And the base over here is 3. So log base 3. And then I'm saying how many 3's multiplied together in, and what was the answer? In 9. So log base 3 of 9. How many 3's multiplied together give me 9? Oh, 2 of them. 3 squared gives 9. So the answer is 2. So this conversion from here to here is a pattern. You start on the left, log base 3, then you go across the equal sign to get the 9, and then you come back to get the 2. The answer in the logarithm is the exponent. And the answer from the exponential equation is the argument here. It's the thing right next to the logarithm. So for a lot of what we're doing, if you choose, you can go at it with a very superficial perspective. And if you just understand this trade-off here, this conversion, that's going to be plenty. That's really what you need to know. We are studying logarithms specifically to help us solve financial interest rate problems and such. So really, as long as you understand how to get from an exponential to a logarithm, that's enough. Now, would I like you to understand more about logarithms? Absolutely. Are logarithms used for other things? Absolutely. If you are living in California or one of the other states, Washington, Oregon, Hawaii, and sometimes, Kansas, if you've ever talked about the magnitude of an earthquake, that number, like if it's a 3.6 or a 5.2, that's a logarithmic scale. If you have ever worked at an airport and had to wear ear protection because the sound level was too high, the decibel rating, that's a logarithmic scale. So logarithms are all over the place. I am happy to talk more with you about it. But again, for 5.2 and 5.3, we're really going to be very targeted with why we are learning logarithms. Just a more quick and dirty version. So let's try the next one. So I've got 4 raised to the xth power equals 16. That's the exponential form. And so for the logarithmic form, there's going to be a log. And I start on the left. Log base 4, because 4 is the base. I go across to the answer of 16 equals x. Now, you might even in your brain be saying, wait, that's 4 squared is 16. So you know what x is. But for this particular problem we're not solving, we are just rewriting. Okay, x cubed equals 9. Now, this one's a little tricky because if you're like my brain says, ooh, 3. But 3 cubed is actually 27. So this is a slightly more complicated problem than your brain might see right away. But we're not going to solve for x. We're just going to convert to logarithmic form. So this is the exponential. I write log base x, because that's my base. Go across the equation to the 9. Log base x of 9 equals 3. So in each case, whenever you've got an exponential form, you also have a logarithmic form, as long as you're following these rules. You can't put a negative number inside a logarithm, and the base has to be positive and not 1. Okay? That's it. And so at this point, you should be saying, okay, but how are we ever going to use this? Okay, so now go to your happy place. Breathe. Remember that I'm going to tell you that no matter what happens, I promise we will survive this. And honestly, I'm exaggerating a little bit. This page is not too bad. Okay, so now for the next one, I've given you the logarithms, and I've said rewrite an exponential form to solve for x. So this is slightly different. Come here, little squirrel. There we go. Again, being supportive, but not being in the way. That's excellent support. Thank you so much, squirrel. I've got the logarithm, log base 3 of x equals 9. And then we have to convert to exponential form. Now, do we have to? And the answer is you don't have to, but at this point, most students in this class don't understand logarithms as well as they understand exponents. So the easiest way to resolve this and figure out what x is to go ahead and write it in its, pardon me, squirrel, in its exponential form. So how do we do this? Well, now we're starting with the logarithm. So we go to the base. There's the base. So we start with the base. We're always going to start with the base. And then we go across the equal sign. And the answer there, the answer with the logarithm, is actually the exponent. And then we say equals x. Now it turns out that 3 to the 9th is not a small number. So I'm going to go ahead and, again, I'll remind you, if you've got a fancy calculator, like this calculator, I'm going to do 3, and then I find the x to the exponent key. Some of you might have an x to the y or a y to the x key. And then 3 to the 9th is, so let's see, x equals 19683. So x is 19,683. If you don't have a calculator where it's written all nicely like this one I like because the keys are all nice and big and easier to read. In this case, my exponent key is going to be that, oh, you can't see that, I'm so sorry. There we go. Is that up arrow. That key right there that looks like a rooftop. I'll point with my, there we go. Ooh, there we go. So this is our exponent. On a keyboard, this is also the exponent key. So if you're working on a keyboard like a desktop or even a laptop, you're working online, that's how you signify exponents when you're not able to actually format them as exponents. Okay, let us try the next one. Log base 2 of 8 equals x. Now at this point, some folks may remember, or they may have just picked it up quickly. Some people, some things come easier to some people than others, and yay for the folks it's easier for, and for the rest of us, we just keep working at it. Some of you may already have an idea of how to solve this, but again, I'm going to use exponential form. This is equivalent to, we start down at the base, 2, go across the equal sign, that gives us the exponent, 2 to the x equals 8. And so solving this problem comes down to thinking, 2 to what power gives me 8? And I know that 2 cubed is 8. So that means x must be 3. Oh, my 3 got very exciting there. Could you solve it like this? Yes, although the problem did ask you to rewrite it. Okay, so what about logarithms? Well, hopefully you remember logarithms, and you might notice that on your calculator, you have a log key and this other one that looks like an IN, but it's actually an LN. And you'll notice that they don't have bases. This log base 2 is nowhere on the calculator. I just have plain log or plain ln. And the same thing goes with the my other fancier, less reflective calculator. That's exciting. It has an ln and a log, but it doesn't have a fancier one than that. Why is that? Well, it turns out there are two logarithms that get used much more than others. And that it's just because of, biology. They're both actually due to biology, kind of, and mathematics. So our special logarithms, common log, if you just see log, see how it has no, so it's just log of something. There's no base written down. That means log base 10 of x. And why 10? Because 10 fingers. Well, technically 8 fingers and 2 thumbs. But 10 digits. Ooh, base 10. Since we're in base 10, log base 10 is very useful. And in fact, log base 10 is the common log is the one that they do use for the logarithmic scales for the most part. So the when you look at, say, earthquakes, or when you look at sound levels, we're using not just any logarithmic scale, but log base 10. Okay, now natural log is one that if you are in the biological sciences, you'll know better why this happens. For everyone else, I think a lot of times folks don't spend a lot of time with this number, but this is ln, which is, it looks like in because it looks like someone just hasn't drawn the I in, but that's an L for log. ln of x is log base e. And you're going to say, wait, what the heck? What is e? And the answer is e is, and I'm realizing that's really hard to see, so let me use my shiny calculator. Also very hard to see, but you'll see right above the natural log key, you see there, if you can see that, that's an e to the x. Same thing here, there's an e to the box. So what is e? Well, e is that number, 2.718281828. It goes on for a while, and then it doesn't actually keep repeating. It is very special. It's like pi in that it does not repeat. It just keeps going on forever without repeating, which makes it not just irrational, but transcendental, which is pretty cool. It has, the not repeating part is not the part that makes it transcendental. It just happens to be like, it's super irrational. It's a very special number. It turns out that this number ends up being a very special base when you look at things getting bigger. So exponential growth, or interest, or population growth, all of these things are actually in when they're allowed to just happen. So if you look at population growth, populations of a small number of, say, rabbits, if you give them plenty of food and plenty of space, they will reproduce and their population will get larger according to this number. It just happens. It's this number. And we'll talk about it more as we get into chapter 6. And I am happy to geek out. Some people love E. It's, I believe it's named after Euler, E-U-L-E-R. His name looks like Euler, but it's actually Euler. And the constant is just a really important number for math. So if you want to come talk to me, we can geek out about E. You can look it up. You could spend days watching videos on YouTube about E. People get really excited. What are we going to use it for? Honestly, we're not going to be very respectful. We're going to use it basically like a screwdriver. We're going to use it, or a hammer. We're going to use it to crack open problems. We're not going to really use it as its own thing. We're just going to take advantage of its properties. So, next thing, let's talk about evaluating these logs. So, if I just see log of 10, notice there's no base. So I know that this is log base 10 of 10. So how many tens multiplied together makes 10? And the answer is, well, you just need one of them, right? You just need 10 to the first power. So log base 10 of 10 is 1. Okay. Let me do the next one. And people usually say, no, don't go on. And I'm going to say, let me do the next one so that we can compare and contrast it. Log of 1,000 is log base 10, right? If there's no base given, but you use the letters log, it's log base 10, it's the common log. And then instead of 1,000, I'm going to write this as 10 cubed. How many tens multiplied together gives you 10 cubed? The answer is, you've got it, 3. I feel like some of you, I could sing the You've Got It song. Lo hicimos, we got it, we got it. Congratulations. Or you're supposed to say, yay! Swiper, no swiping. Okay, next one. Now we've completely shifted gears. I've got ln, and remember that that's an L for log, right? ln of e is log base e of e. How many e's in e? Well, just one of them multiplied together. Anytime you get a base and an argument, this number right here, that match, log base e of e is 1. Log base 10 of 10 is 1. Log base 3 of 3 is 1. Log base 5 of 5 is 1. We could do a whole dance if you wanted to. Okay, so I'm going to stop there because this video is now 22 minutes long. And I'm going to give everyone a brief break so you can go get some snacks and something good to drink, get something snuggly. Make sure you've got, some helpful, supportive folks in your life telling you you're awesome. You can totally do this. So remember that you're awesome. Remember that I believe in you. And math on, and I'll see you in the very next video. Woohoo!